We're ready to start. Good morning, good afternoon, and good evening, everyone. Welcome to another Alluxio Product School. I am very thrilled to see all of you here today, and my name is Jasmine. I run the open source community effort and developer relations at Alluxio. So if some of you might not be familiar with Alluxio, or if this is the first time you tune in into our product school, if this is the case, a warm welcome to you, and thank you for checking out our event series today. So the one that you're looking at today is the product school series, where you will hear some industry trends and insights from our researchers. And we'll also have another event series called Alluxio Day, where it will feature some open source contributors, developers, and other relevant open source tech stacks. You can find all of our past virtual events presentation on our website, and then the slides and video recordings of today's talk will also be shared after the event. So here with me is our speaker, Jingwen here. And Jingwen is a product manager at Alluxio with over 10 years of diverse data experience. And before Alluxio, she has worked as a data engineer at Meta and SanDisk. Jingwen has also received her bachelor's and a master's degree of EECS from MIT. And she's also a proud mom of her 2-year-old border collie, adorable dog, and a certified snowboard instructor, and has a strong passion for basketball. So today, Jingwen is going to talk about deconstructing a machine learning pipeline with virtual data lake. At the end of the presentation, we will have time for live Q&As. So please go ahead and submit your questions during the talk on our Slack troubleshooting channel, and I will help you to redirect the questions to the speakers. If you have not joined our Slack yet, go ahead to alluxio.io/Slack, and that's where you're going to find us. And a list at the bottom of the slides. However, if you have any trouble joining the Slack channel, you can also feel free to submit any question via the webinar platform for Q&A. So without further ado, let's hear about deconstructing a machine learning pipeline with virtual data lake from Jingwen. Go ahead, take it away.
Thank you, Jasmine. Yeah, I just hope my dog doesn't decide to speak too much during the talk. So today we're going to talk about the machine learning AI pipeline a little bit. The reason I started thinking about this was sometimes for someone who hasn't been in this, like using machine learning or AI, it just seems so mysterious and also very prestige. And people probably don't know where to start. And then for people who have been using machine learning and AI, then this hopefully will provide some use cases and to see how, the virtual data lake can help their pipeline and make it faster. So yeah, let's start with the introduction a little bit with the background. So here is we hear a lot of terminologies around AI. There's AI, machine learning, and deep learning. And sometimes we wonder what they are. So even though AI is something a little bit new or trending in hype these days, but it's actually started from 1950s. It's way back. So people have been studying artificial intelligence for a long time. What does AI mean? It basically means intelligence demonstrated by machines rather than human or animals. And then for machine learning, it's a subset of artificial intelligence. So we give the computer the skill to learn about without explicit programming. So we don't have to tell them to go from step 1 to step 2, but maybe they have some algorithm, even from the simple ones. For example, sometimes even logistic regression could be counted as part of that. So at least they can make some learn about what's happening. And then for the deep learning, it's a subset of machine learning. And then it you see that in the picture, there's a brain, right? So basically it learns to improve on their own, just like our human brain. And then usually this is done by natural neural network that consists of more than 3 layers. And those are neurons that people say. With this, and how does this relate to data, right? So there is a diagram between the model performance and the data. with the traditional machine learning, the performance is like mediocre, and with a smaller neural network with more data, it's much better. And then as we get more and more data, and with the compute is getting better, then it's a bigger neural network, and it can do a lot more computing and learn about more complex things. So the performance goes way up there. So this is the relationship between them. And then there are a lot of use cases of AI. So here I know this is a bit busy slide, but we don't need to look too much into the words. Just say that there's a lot of industries we already using machine learning. For example, if we just look at the healthcare, there's like patient care, there's management for retail. They're trying to figure out what's the inventory we should have. So all of these, there's artificial intelligence in there that helps our daily life. So the message here is that AI has a wide variety of use cases in different industries. So we really want to leverage it so to make either for our own business to have an edge, or like just in general make our life better. And for machine learning, there's a common learning process. So when we feel like it's very mysterious because we don't know how it works, right? So here we deconstruct it into like 5 stages. The stages are, at first, we need to collect the data. Then once we have the data, we try to clean the data. Once the data is clean, it gets passed into, so the data plus the algorithm becomes a model. So that is what called like the model training. After that, we want to evaluate whether this model is good or not. Finally, with that model we produced, we want to make some predictions, which is also called the model inference stage. So later we'll talk about the stages one by one. Now, let's see what is the virtual data lake layer. And then for us, we have built Alluxio, and it's the virtual layer between the compute and the storage. So all the component up here, Presto Spark, which people familiar in the big data analytics world, and also some like TensorFlow, PyTorch in usually like the deep learning world. So those are the compute that we integrate with. And then there's a lot of storage also. For example, the Amazon S3 and like Google, there's also like Google Cloud Storage, Microsoft Azure, the Hadoop one, which is like HDFS. So all of these are the storage that we integrate with. So what's the key features of Alluxio? Basically, we are a unified namespace that provides a single point of access. So like all those storages, usually if we have to access them, each one have to have a access point. But with Alluxio, we provide a single point of access, and this eliminates the silos in the data lake. So if you cannot see some of them, and then, or if it's not convenient to use, then that part either becomes obsolete or some team started developing silos. And then we also provide a server-side API translation. So for example, if we have many different client-side APIs, for example, if people build their client to use, say, HDFS interface or PostX interface, they don't care what the storage down underneath is. And then Alluxio does the translation for them. So basically, we enables any compute to access any storage, and then the compute application layer can be portable in that sense, where you can take it from different places and then you can use them on that. One more key feature is that we provide data access as a cache layer. So when we have the data access, some of them like Amazon S3, for example, it's coming from the network, right? So the network is a limited pipe. And then when that is full, that's the limit of how fast our data can come in. But if we can make it local with this cache layer, we accelerate the data access when we do the compute, and then we also offload the stress from the underlying storage. So, and then Alluxio actually shines in all AI life stages, and we'll talk about that in the next stage when we deconstruct all the stages here. Cool. So let's talk about the first stage, which is a data collection. So there's a center of gravity, like data collect from a universe of sources. And then you can see there's IoT ecosystems. For example, there's camera, there's or like security cameras, there's sensors, or there's like even these like a windmill, they have sensors for like a maintenance, for example. And then for our mobile apps, there's a lot of data being collected. I used to work at Meta, so then also like clicking where you visited, your likes, they're all collected too. So the data is everywhere, and it comes from a universe of sources. And this can be also collected in many different ways, like the sensors and then the social media, they're all collected through, some through just like your phone, some through the very specific machines. So the ways that they're collected are very different. And then, well, let's not look into too much into the text, but again, depends on what are the business use cases, we get different data types, like there's images, there's videos, audios, and text. So all these are dictated by the business. So as a data practitioner, we encounter all the different kind of types without our control, right? There's no way of consolidate them into just only images or only text, or even in images, there's different type of files. So we cannot control that in a sense. So we can only just get the data and try to go from there. And then once we get the data, usually the data comes from a edge device, all those sensors we talk about. And then usually data flows from the edge to the core, and then finally to the cloud these days. And then data has volume, which means there's a lot of data. It has variety, there's different types, and it has a velocity, which is there's always a need for speed so that we can get the insight faster. So with this, we'll showcase a case study that we did with so Expedia, which is the world leading online travel service, and it's a very large travel agency in the US. So what they used to do when they collect the data, some background is that they have sometimes companies acquire different subsidies, new components. So each company may started with certain data centers, right? So maybe they're in different regions in the same region, but there's a different data center. They try to if each subsidies may process their data in different ways. So and then there is a central main data lake that does the central processing also. So all those data from the subsidies gets copied. This is the original method. So the data is replicated from those either public cloud or maybe another data center into this central data lake. So this causes, because this comes from the network, there's a poor performance. We need to copy, and it's error prone. What if the copy fails? And then there's also, for example, for S3, whenever you pull data from the cloud, there is a cost, right? So this is called a data egress cost. So every time you pull them, there's a cost. And then when the data gets copied, before it gets copied again, the data may have changed in the subsidy area, but then in central place we haven't get it, then there's a synchronization needed, otherwise they're different, right? So the insight you get will be different. So now the solution that we get with Alluxio is that we provided a no copy data solution with our unified namespace that we mentioned. So this way Alluxio sits in between, and then we can access all the data directly. And then when the data is accessed at the first time, we read it as code, and then it gets cached in Alluxio. And then if we need to use that data again, we read it from this cache layer directly. So usually people, like a different business, if there's multiple teammates or even for between teams, we might use the same data. So for example, the user information usually is reused and then get joined with many other type of data. So that data can be cached, and once you cache, it becomes local, so it's much faster. And then we don't have to pull the data over and over again. So for XPDX case, they actually saved the data egress cost for 50%. I see there's some questions coming in. We'll try to answer them at the end. Yeah, please do keep asking the questions. For the second stage, we have a data pre-processing stage. So there's many approaches, but I'll just pick a few. For example, for this one, we need to format the data, right? So when the data coming in, maybe this is an Excel sheet, then we have to put them into a structured table so that the analysts can query the structured data. And then sometimes the data come in category, so we need to like transform the categorical data into numerical. Another example is the images. So for example, this image is someone's face, and we need to decompose that into some features that the algorithms can take. So this actually eventually becomes a vector that numbers that people can take. So this is a lot of data, very complex, and it's compute extensive here. And from our the surveys and from our customers, we found out that machine learning engineers usually spend most of their time on the data cleaning stage. And then 30 to 40% of the companies, they say their pinpoint is in data cleaning. So this stage is very important. And then one case study we have is with Tencent, which is the currently the world's largest mobile game. So I'm very excited about this case because I also play the mobile games. So if people in the US familiar, there's like the OL, Dota. So yeah, this is like for this Honor of Kings, this is a highest gross mobile game of all time. And there's upward of 80 million people playing it each day. So that means there's all the data used to support this game is in high concurrency. So a lot of people accessing at the same time. And then before they had, so for them, they had 1,000 application nodes, and then their application pods. So this is their Kubernetes container. And then with Spark, they do the feature extraction that we talked about. So there's locations, there's like who they are. So all these becomes a feature in their data processing. So if we look at this box as a node, as like a single machine, so they have their Spark in there. And then they also have the Ceph as the under file system. So if you think about 1,000 of these trying to access the Ceph UFS at the same time, it will overload, and then it will probably not even able to support that at all. So the solution that we provide is we add this middle layer of Alluxio. So then we can add a Alluxio worker pod with the Spark application for each node. Here we do the co-located deployment where they can be local. So once the data gets pulled into Alluxio, it's local to Spark. And then the data is pulled once on when this data is accessed. So everything else is warm in Alluxio. So when they do the feature extraction, they can just read from Alluxio. So this effectively offload the stress from the underlying file system. And then also, because it's collocated, it's much faster. When we are collocated, there's a shortcut. So it's very quick. Yeah, so this also solves the high concurrency problem. So there's no 1,000 node trying to access at the same time. So yeah, so this is one of the feature extraction case. And then let's talk about the training once we have the features. This is a very dumbed down version. I know the training is a very complex process. So here we will just talk about like a little bit concept. We have from the data point of view. So there's an original data set. It gets split into training set and test set. The training set is further divided into training and validation. So it goes through iterations. So you can like the validation, just a side note for deep learning, because it's very expensive. Sometimes they avoid this stage, but we can see that the data usually gets divided into a certain way. So either training data 80% or down to like 60%, depending on how people want to use it. There's no like a set rule, but the training data, validation data, and test data, even though test data usually is smaller, but it's still probably like 1 to 10 kind of scale. So all those data set, the scale is pretty large. And then what's the problem in training, right? So if we look at this, each epoch, so this means when the data is, all the data is seen by the like when we train, every data has gone through once. And then we also go feed the data into the training by batch. So even though we can divide it into many, many batches, but the data loader, when they load the data in, it still takes time. So when the batch of the data coming in, the CPU and the GPU, depending on how, this is just an example, but they could be just GPU directly, and then they will be waiting. So during this orange time, it's waiting. So once this data is in, it can preload the next stage. And then this is when the training starts. So if the data loading time is longer than training time, there's always some wait time here. And then this is called IO stall in training. So, and then for inferencing, because the GPU utilization rate is very important, was because once the GPU is on, there is electricity burning, and then that is money. And then, so all those wasted time is money also wasted. So usually this is one of their goals, to maximize the GPU utilization rate. Then for the machine learning engineer that we talk to, usually the end user, maybe they don't, the money is a little bit farther from them. And then the time may sometimes maybe not as sensitive per se, but what they want is they want more data, they want better data, they want a bigger model, but running a bigger model, it will take more resource. So that means if we can get this GPU utilized faster, everything runs faster, the resource gets reused quicker too. So this is what we have seen, some of the pinpoints or bottlenecks in the training stage. And then with Bilibili, we also have a training case study. So this is a video sharing company in China. So sometimes they're deemed as a China's YouTube. So people can upload their videos and share. There are also about like 80 million daily active users for Bilibili. And then before, when they have this container, their underlying store ROSS, which is a cloud storage, and then there's also the HDFS, which is a Hadoop system. So the training container used to download the data every time they try to do something. And then because it's container, sometimes the pod might die. So they have to restart one restart of the pod, they need to re-download the data. So sometimes that can go into a cycle. So with Alluxio, there's no more re-download because Alluxio can cache the data. If the container dies, the data is still in Alluxio, and then when the container comes up, they can just pull the data directly from Alluxio. And then there's another problem associated with, even though with the cache layer, if this is a single machine, we cannot hold that much data, right? So then this comes to the distributed feature here. So if we have multiple workers, and this can go horizontally scale to many more. So each one of them can serve to certain compute, and then this way we just distribute the load. And then one more benefit of this is that the compute simplification and portability. What do I mean by that is when we have different underlying storages, sometimes they have different protocols. So for here, they have S3 and HDFS. So their application has to write in two protocols. Then that's like duplicate work. With Alluxio, they use the POSIX API, which is a very generic API, and then Alluxio does the translation into S3 and HDFS here. So the application layer can be drastically simplified, and they can be taken to any storage. So we call it like the vendor locking is no longer exist. So you can choose any vendor anytime, you can swap and get a new one. Cool. So then once we have the training model ready, the model is ready, then we have to evaluate the model. So what is model evaluation? Basically, it's a method of assessing the correctness of models on the test data. And for this, there's a lot of challenges. One is a methodology. It's a very statistical process. And then data quality and data quantity is always a problem. The compute is very intensive. So if we look at the methodology, I can read them, but it doesn't, I don't know what they mean, but it's a very statistical process. So it's like very sophisticated. And then the compute is also very intensive. So sometimes people think the training is compute intensive, but given that the test data is maybe almost like 10% reduced by maybe 1 magnitude, but it's still very large. So the compute is still very intensive here. And then here's one example of the Fortune 500, or it's actually like top 50. So the solution, so I won't go into like how they get to the current stage because it might look similar to the previous stages, but here I'll mention like what they currently use. So they have Spark and Trino, which is very typical big data analytics or like big data framework, not just in analytics. So with this cache layer, they also we accelerated this hybrid setup, which is there's also on-prem, there's also AWS cloud storage. So they start to move some data into the cloud, which is a journey that people start to take these days, coming from on-prem to the cloud. So before they migrate everything to a cloud, they become this like hybrid system. Or sometimes we see that there's still importance of on-prem. So maybe people will never go all in cloud. And then if there's one cloud, maybe there's sometimes they want multiple cloud, depending on their cost and like performance. So this enables that just by pulling the cloud data into Alluxio. And then this shortens the time to insight, because with the cache data, even the cloud data becomes local. Again, we mentioned the reduce the egress cost. Then we can access the data. So all these are kind of mentioned from before. So I want to talk a little about the achieving a future-proof architecture. So what does that mean? So earlier we're just pulling the data, we're just storing the data here, right? So but now maybe we can have compute in this cloud, and there's compute in the on-prem, depending on the load or like the team that's using it. So with a load balancer, the load balancer can put the data or the compute into different, so like different in this like topology, where whichever make more sense, which is less busy, we can run that. And then the storage can be anything. So this enables that elasticity. So the compute can like scale horizontally. We can add more or like just take out when we're not using it. And then with this load balancer, again, we can get the so that you're not like only hot in one area, right? So this is the future plan here. Okay, with that we come to the inference. So now that we have a model ready, and then we need to serve the prediction, right? So there's a little bit about the inference. There's offline inference, there's online inference. The purpose of that is all process the running data point into a machine learning model, and we need to calculate an output, such like to get a single numerical score. So then I'll talk about some examples after. And then this actually becomes a very similar data flow as training. We need to go through the same feature extractor here. So that means the compute is still very intensive, because if the features are different, the model won't calculate it properly, right? So the difference between offline and online is that offline is done in batch. So it usually at the same time, there's a large amount of data. So sometimes one of the popular tool is Spark. The latency is somewhat acceptable here, and then the result is stored, then it's being served. So it's more acceptable is in comparison with the online one. So this one is usually, for example, I'm using my phone, and then immediately we have to serve something to the user, or like, for example, in a manufacturing process, right? There's like QA, for example. So like if there's a robotic arm, we need to know whether that chip, for example, is bad, we need to throw it out or not. So this needs to be known very quickly. And then this is tend to be somewhat interactive. So for Tesla, the autonomous driving on the road, if we detect there is an obstacle or there's a person, we need to know right away and take actions. And then the Uber Eats also calculate the estimated time like right away too, right? So these are some examples of online inference. And then for offline inference, some example I found was, for example, the Amazon product recommendation. So if I go to Amazon, I probably don't need a new product every single time I log into it. So some of that can be done in batch, but not necessarily always done the same way. And then we also, one example is Microsoft Bing search result. So Microsoft, I think I don't need to introduce a whole lot. It's the largest vendor of computer software in the world. So what they have is actually, as I mentioned, the training and inference is almost the same. They do the read and write. There's a policy, they cache the data. The data storage, there are many different kinds, their own Azure storage, there's HDFS, and then there they adapted a job scheduler. What does it do is that when there is an inference job, the scheduler knows to prefetch data into different, like the compute pods. And then this prefetch with a scheduler into Alluxio cache allows the job to execute immediately without the IO store that we mentioned before. And then we provide read retry also. So with this preloading, sometimes when we read, if it fails, then we actually, it's kind of, we need to go back and read them, and Alluxio provides that benefit too. And then it allows customize cache replacement policies to make the inference job more efficient. So we actually improved the performance by about 18% for this case. So we mentioned all the stages. I'll do a little bit summary. So hopefully this has demystified the machine learning, AI, deep learning a little bit to the audience. If you haven't using it, it will seem not as like complicated or prestige in that way. And then by deconstructing that, we give a like how to start in each stage, like, and also we provide a way to improve each stage. So Alluxio as a common layer, we can be in all the stage of machine learning life cycles. I want to give one more example of Biggie when they use Alluxio in 2 stages. So for example, there's data pre-processing, which is a cleaning, and then the model training. What they used to do, when they pre-process, they get the data from the OSS. The data is saved back into OSS. The model training pull the data back from the OSS and then maybe put the model back in, or during the process, you have to write data. So with Alluxio, what they do is this is a cache layer. So the data, pre-processed data can be cached and then immediately serve the model training. At the meantime, Alluxio can write the data into OSS so that there's no more of that pulling it back out process. Yeah, there's some focus on Alluxio. Usually we're on the data volume when there's a lot of volume, and there's data silo, there's a need for speed. So usually it works well on when we have a heterogeneous compute and storage systems. And then there's a heterogeneous topology, for example, hybrid, multi-cloud, or plus on-prem kind of topology. And when the IO becomes bottleneck, that's when Alluxio can help and shines. So yeah, thanks for attending. And we have a Slack channel here. It's a very active channel. People can ask questions. We'll also usually get back pretty quickly. And then, yeah, let's get to the Q&A stage then. Jasmine, you want to help?
Yes. We actually have quite a few questions coming.
Yeah, thank you
from Ashwin. Yeah, thank you, Jingwen, very much for the great presentations. We'll get to them immediately, so let's see how much we can address. And also, by the way, for those of you, you can see on the screen that Jingwen has pointed out where our Slack channel is. We already have people, core maintainers, start trying to help her to answer your question, just in case we haven't got there yet. And for those of you that if she doesn't have the time to address, or we need more time to figure that out to get back to you, you can always loop back to the Slack channel too. Okay, so the first one from Ashwin. There seems to be a mixing and match between the storage layer, something like HDFS, and a file type abstraction, something like Avro, and eventually the table layer, the things you do not see here, and then the Delta Lake, Hootie, and Iceberg. Actually, we do work with those. Can you comment on how Alluxio works between all these 3 layers? So basically, he's asking between the storage layer, file abstraction, and then the table layer, how Alluxio works with those 3.
Yeah, so I think between the file abstraction, so like there's Avro, there's Parquet, right? So to us, I believe they're just a file format. So as long we don't really process the content of the data, we just move the data, right? So as long as it's a file, it's okay for Alluxio to move around. So that's not a problem. And then Jasmine mentioned the table layer. We do have, especially on the community side, we do have support for the Iceberg. And then between storage, yeah, HDFS, S3, so they are, we call it like more like a southbound API. So it's kind of like API translation. So that's between the client API to the storage API. We do that translation in between. So I think that's how I see the difference and how they tie together for the 3 layers. Yeah.
Cool. And then we have a second one. I don't know whether that is in our expertise. Also from Ashwin, is there a data egress cost in S3 within different regions as well? I thought it was just if it was taken out of AWS. Do we happen to know that?
I'm not as familiar in this one, but I feel if the data every time it's pulling out, it will cost money, right? So if different regions pulling them out at different times on their own, I feel like that will cost money. But if they pull it once and then they do the copy locally, then that's probably okay. And then with Alluxio, we pull that data into Alluxio, it kind of distributes or like it sends the data to the compute. So that becomes once you put the first time, then we don't interface with S3 for the same data again. So that's how we save that cost.
Cool, thank you. And then the next one, that is on Expedia. Actually, we have someone try to answer that for you, Ashwin, on Zoom platform, but I'll ask that again in case Jingwen has more input. It looks like Expedia is using your caching ability to reduce S3 egress cost. However, with materialized views, you need the most up-to-date data as well. So how do you account for those type of questions, for those type of queries, which usually take a lot of types of queries and you would see in a real time and up to the second site, like Expedia?
Yeah, I haven't looked at the Slack response, but from my understanding, I think Alluxio basically pulls that data actually into the cache layer. And then we do have the up-to-date data. So Alluxio probably will save more warm data in there, so as a cache layer. And then when we access more data, we will pull based on that access, we'll pull them into Alluxio if they're like if they're up to speed. So usually we have the new data in there, and then those queries, I believe those data will be reused multiple times, right? Like one person may be trying to like search for a hotel, another person, same thing. So all those data can be stayed in Alluxio locally. So you don't have to pull from S3 over and over.
So I think Shoei responded to, so just to chime in that if you are already a Alluxio user, Ashwin, Shoei actually provides you to a specific setting where you will be able to get the latest data every time, where we check the metadata consistency every time. So that's how we actually work with that. And on top of that, getting back to that, I also responded to your thread on Slack channel. In case you're interested, I've added a hoodie case where Alluxio work with hoodie to answer your first question. All right, save time. We'll jump to the next one. Jim, when you're ready. So Ashwin had two questions about the Tencent case. One is, why is CFFS instead of some other file system? And two is, I see that it's a classic master-slave architecture without containers. Is there something done on the network side as far as putting an ingress controller to ensure no latency issues?
Okay, for the first one, I think it's their choice that I'm not as familiar, but maybe in the Slack channel, someone who worked with them closer could answer that. Let me see. I don't know. Yeah, so I think there's some details, maybe the engineers will know better, but we'll get that question in Slack and get answered there. Yeah, thanks for the question though.
So I'm tagging, so Ashwin, if you were looking at the channel, I did tag one of our Tencent PMC who is in charge of that program, so he might have more input on that. All right, next one. I do have quite a bit. So for the predictive machine learning, as opposed to the EDA, laboratory data analytics, analysis machine learning, does it fall into the offline or online type of inference? So this is back to that online offline inference that Jingwen is talking about. Whether the predictive machine learning,
yeah. Hopefully that page was, maybe it was a little bit busy, but with we do see like the Bing, Microsoft Bing, they do a heavy offline inference. Maybe there's so like if I would say if it's a common phrase that you search, probably those results can be predetermined, and then they probably have to train validate a lot whether those results are correct. And then for the online training, kind of like Tesla is very typical, or like a example for the online one. So there are people definitely use it on both sides. So I think for like Meta, even like not every, like for example, like if they want to show ads, right? So maybe not everything is online. Yeah, so I think like sometimes even though we as a user see it right away, the result may be prepared beforehand. That's where the offline comes in. But yeah, before I do the research, everything seems online to me.
Yeah, got it. Okay, one more from Ashwin. Azure only provides coarse-grained controls and not fine-grained. Is there a way to around this when utilizing them for machine learning?
So I'm not an expert on Azure, so maybe someone on Slack channel can help. But then my comment on this is, if Azure is not the fine-grained one, if you want to pair with another storage that can be more fine-grained, so you don't have to like pick and choose, but you can have both of them with Alluxio, where you can just direct your load to the appropriate one when needed. And then if you find the one you don't like, you can port the client to another one, given that the API translation makes it easier. So there's definitely freedom to choose. I think that's what I would try to say.
Okay, so thank you, Jingwen. Those are the questions from Ashwin. I did have my questions too.
Okay.
If I'm allowed to ask, I think we still
not
have
off the hook.
just a little bit of time. Yeah,
Okay.
I know. And thank you for, Ashwin, for being so active and asking us a question at the end. So I noticed that you did share some of the cases that are Community Edition and Enterprise Edition. This is also giving me a chance to, let our listeners know, in case you're not quite familiar with Alluxio yet, we do have two different versions of Alluxio. One is Community Edition, that is open source. The other one is Enterprise Edition, which is not open sourced. So and then I want Jingwen to see if you can elaborate a little more on what's the difference, since you mentioned some of the cases are from the CE users, some of the EU users, share the benefit of the EU versions and then some of the differences.
Yeah, so usually the functionalities are mostly there, but from the EU users, what we hear is that they want the enterprise grade security. So what does that mean is, so sometimes there's computers storage, and then if you want a centralized like authorization kind of control of data governance, so we have a Ranger plugin or like Styra OPA kind of open policy agent. So that can provide a central authorization and easier to manage. And also, we also have like authentication, which is Kerberos. So like authentication authorization is a big part of the enterprise offering. And this is not available in the community edition. And also, given the enterprise security, there's also encryption. By encryption, we mean one is data at rest. So when the data is in Alluxio, we can turn on the option to encrypt it so that anyone, if they somehow got the disk, they cannot just read the data. And also there's during the transportation, the TLS protocol, where between the client and server, or when the data goes between the Alluxio master or worker, the data is secured by the TLS protocol. Beyond the security, there's also other benefits I can think of. One is transparent URI. So when we do the unified namespace, when you have S3 protocol, HDFS protocol, usually when we do the link will be S3 / or HDFS // in the community version. The way we make it into single point access, we change it to Alluxio // so everything is under that link. But with this transparent URI on the client side, they can still as S3 or HDFS, and we do the translation in the background. So this means that your application link doesn't have to change anything, and then the catalog in the table, so usually when we define a Hive table, we have to define like where it's located. So that table definition can stay as the HDFS or whatever header used to be. So this reduces the amount, like this eliminates the client changes that we have to do. So those are something come to my mind, but there's also a on our web page, we have an edition, so there's more details on there. Yeah.
I'll tap that on Slack too. one last question. We have about 7 more minutes. I think you can wrap this up. So I know you've shared the case study for each stage individually with the different users. So you dissect into 5 stages. Do you see Alluxio being the middle layer for all stages throughout for one user?
Yeah, I think I can see that with the big example, they use it for the data cleaning and training, right? And then we also see that the validation, sometimes even inference, they kind of use the same stack, like a popular one maybe like Spark and then S3 kind of combination. And then given that training and the inference sometimes use the same feature extractor. Actually, feature extractor is in the data cleaning part. So all of these I can see, if we choose a similar stack, we can totally use Alluxio in there very easily, even though if it's not, given the API portability or like the translate between the APIs, I think I can definitely see we use Alluxio as a layer. On top of that, as a big case where, because it's a cache layer in between, when it's across all stages, we can pull the data between the compute and Alluxio without going to the cloud. I think that can speed up the data too. So definitely, yeah, I think that's a definitely good use case there.
Cool. Thank you so much. That's a wrap today.
Thank
All
you.
right. We appreciate you giving a presentation, and then that's it for today. And I hope all of you enjoyed our talk. And then, like we said, we shared, we will post the video as well as the slides after we get this wrapped up, probably end of the day today or by tomorrow. And please do join our Slack channel for more discussions. That if you have questions for Jingwen, she's always on there as well. Feel free to tag her or shoot your questions away. Thank you so much, everyone, and we will see you next time. Thank you, Jingwen.
Yep, bye-bye.